Now, for class 11th, from the very first chapter, which is called Kinematics, we try to find out and understand the basics of kinematics from various aspects. In this lecture, we will talk about numericals for kinematics, and that specifically in one dimension only. We will make the series in 3-4 parts. In one case we will talk of differentiation, in one we will talk of the graphical things, the graph and its interpretation, and in one we will talk of the numericals and then derivations as well. Let's talk of this numerical. There is a figure, a red car and a green car, identical except for the color, move towards each other in adjacent lanes and parallel to an x-axis. At time t equals to 0, the red car is at xr equal to 0 and the green car is xg, which is 240 meter. Red car has a constant velocity 35 meter per second. The car pass each other at x is equal to 140 meter. What is the velocity of the green car? In this case, the diagram is already given. We should see the red car is moving towards right, green is moving towards left. The distance between them is 240 meters. Okay. We have to find the velocity of the green car, knowing it's a constant velocity, and we know the velocity of red car. Now, red car has a velocity of 35 meter per second and it has travelled 140 meter because only then they are crossing. Now, since the red car is travelling 140 meter at the speed of constant speed of 35 meter per second, so the time taken will be 140 divided by 35, because by the formula distance upon time is velocity, we can find that it takes 4 seconds for this event to occur. That means in 4 seconds the red car has reached 140 meter. Now, since green is also moving, initial distance was 240 meters, 140 is travelled by the red car. Obviously the green car has to travel 100 meters because 240 minus 140 is 100. But secondly, one more thing is very important, that the thing should be that it has to do the same distance in the 4 seconds only, same time only. So velocity of the green car is given as 100 by 4, this is 25 meter per second. So in this case, we find the velocity of the green car as 25 meter per second. We now change this same numerical with slightly variations. In this we have again the red and the green car. We have just made a small difference, that the distance between them is 252 meters. And now we try to find the difference. Red car has a constant velocity of 35 meter per second and the car passes each other at 140 meters. What is the acceleration of the green car if initial velocity of the car is 20 meter per second? That means in this case, the green car is moving with certain acceleration as well. We will see the diagram here in front of you. Now, again the first thing is very clear, that red car has to travel 140 meter and that also at the speed of 35 meter per second. That means this event will occur only at 4 seconds as in the previous question. Now, in this 4 seconds again, the green car has to travel 252 meter minus 140 meter. I repeat, 252 meter minus 140 meter, which is 112 meter. And its initial velocity is 20 meter per second. The green car travelling distance is 112 in 4 seconds. So now equation gives us S is equal to ut plus half at square. Our S is 112 meter. U is 20 meter per second, T is 4. We use the formula ut plus half AD square, that is 112 is equal to 20 into 4 plus half A 16. We get 8A is equal to 32, which categorically gives you that velocity is 4 meter per second square. In the previous question, the green car was moving with constant velocity. In this case, the car is moving with some acceleration and we had to find the acceleration. Right? We slightly again a level higher of the same numerical. In this case, the distance is again made to 40 meter per second, but initial question, See the differences now. Red car has a constant velocity of 57 meter per second. The car pass each other at 171 meter. And if the constant velocity of 23 meter per second, they pass each other at x equal to 115 meter. You have to find the initial velocity and constant acceleration of the green car. In this case, the green car is again moving with some acceleration, but that's initial velocity. We cannot straight away calculate it. Over here now, let's see. The cars are shown as it is there. Again, the first part, we travel 57 meter per second and the distance traveled is 171 meter. So obviously 171 divided by 57 gives us 3 seconds for this event to occur. Now, in 3 seconds, the distance to be traveled in the first case, in 3 seconds, the distance to be traveled is 240 meters minus 171 meters, that is 69 meters, again in 3 seconds. Now we use the equation S is equal to ut plus half at square. S in this case is 69 meters, u is unknown, so but the time is 3 seconds, so I write 3u plus half a into t square, which is 9. In this equation we have got two unknowns, u and a. That's why they have given one more data. In the second case, he says velocity is 23 meter per second and they pass each other at 115 meters. So now in this case, they will be meeting after 5 seconds because 115 divided by 23. Previous case, it was 3 seconds. But now the distance to be traveled by the green car will be 240 meter minus 115 meter, which gives 125 meter. It has to travel in 5 seconds. So it gives 125 into 5u plus half a into 25. These are the two equations having two unknowns. Now we solve simultaneously. We solve it and we get the value of u comes out to be 20 meter per second, as well as the acceleration comes out to be 2 meter per second. And that's how we solve. We have just made slightly changes, and ultimately the equations what we have got, as the question varies, we must try to visualize the question. In this case, you might find the velocity of 57 meter per second and 23 meter per second are exorbitantly high, but they have been taken to make the numerical part simple. So that's it. In the next slide or video, we'll talk of certain more numericals, again from level 1 to level 2 to level 3. Thank you.